is still a work in progress, but when it's completed, ideally it will be pretty good for the game Toss-Up, which essentially is a game about various scoring zones. So we have several different zones. Each one, when you get a scoring object into one of the zones, it's worth a varying amount of points. So the farther away the zone, the more points. The bigger the scoring object, the more points. In addition to that, there are several tubes scattered throughout the arena where if you place a small scoring object in, you get points. Place an object on top, more points. Then there is also the main problem, a 2-inch bump separating zones. In order to get anywhere near them, you need to somehow go over the bump. So it might not look like much, but from a robot's perspective, it is a bit like Mount Everest. So, yeah, we have that. Then there's also a 12-inch bar. So we want to get under the bar, which means we need to somehow get over 2 inches, but also under 12 inches, which is quite a feat.
Also, there's an 18 by 18 by 18 limit on our robot, so we can maximize length because of 18 by 18 by 18.
So our solution to this to this problem so far is the robot we have here. So the original design for the chassis, which is the base here, this part, ignoring the towers, was to have, to help conquer the 2-inch bump, we were going to have wheels that we thought would be, when attached, would have 2 inches of spare room so that this part of the chassis that the wheels are attached to wouldn't grind on the top, because if it grinds on the top, it's not going to get over. We realized a mistake halfway through that our measurements were a bit off, and that those huge wheels would not prevent this part of the chassis from scraping on the 2-inch bump. So what we decided to do then was switch to some sort of a 6-wheel design. That way that the space in between these wheels was small enough so that it would easily be able to go over the bump, and the bump wouldn't be able to reach up and high enough to touch the chassis. We originally did this with 6 of these type of wheels. With these 2 free spinning still and these motors controlling the back 4, we were told that we should have the front 2 wheels be omni wheels if we're going to have them be free spinning. That way when this is turning, these can skid along easily along the ground because of these wheels here, they can spin sideways. So we decided to do that, and then when we were working on that, we realized an issue. These wheels, if they're on the same height here, they're touching the ground, but the issue is that these omni wheels are slightly larger than these smaller wheels. So these would be on the ground, these would be on the ground, but these would be raised even just slightly off the ground. So these motors, when they were running, they wouldn't help at all, they would just stand there and spin. So we decided to raise these up a little bit so that they were at this height and they could still spin easily and still hit the bump first so that they can help climb over it. Another thing about the chassis is that our original design was to have these parts here, which connect this part of metal to this part of metal, allowing 2 points of contact for the wheels. These were originally on the outside, and it worked well going forward over the bump, but when going backward over the bump, that part of the metal would hit first and wouldn't allow it to go over. So we moved this forward a little bit so it could still hit the metal, and moved this backward a little bit so it could also hit the metal on the way back. Now as for the tower, we had an idea originally of an intake-outtake system because taking these buckyballs, we figured we could have multiple ones fit in some sort of tube system or something of that sort. So what we decided to do was we decided to have an intake-outtake system, pulling the balls in and pushing them back out into the tube, into the scoring zone. Now, we started doing this, and we knew that from past experiences last year that just our regular motors turning one arm wouldn't provide enough power to lift the arm. The arm's going to be heavy. So we decided to have a little bit of a gearing here so that there's 2 motors on each side, each spinning a medium gear, which are both spinning a large gear. The large gear will have the arm attached, which is a 6-bar linkage, somewhat like so. So if you have another piece of metal attached here, another piece of metal attached here, when this turns, it goes like this. And then if you wanted to retract, you could just stack it back together like this. So it can compress really well, it can extend to a really high height. So we decided to go with the 6-bar linkage design, and we figured that at the end here, we have the intake-outtake system that could, when regularly compressed, still pick up buckyballs.
Right.
Yeah.
Yeah.
So what grade are you guys in?
Seven.
Did I ask you that already?
No.
Good. Sometimes I ask the same question twice and it scared me. The grayer my hair gets, the more I ask the same question. All right, go ahead.
Yeah, well, that's the actual Vex world, but Vex also helps in the real world. It helps us on a social level and an academic level, really. I mean, I met Henry through Vex, and he's become one of my best friends. And I met James, well, I've known him since elementary school, but I think Vex has really helped us come closer together. And the whole Vex competition, if you ever go to one, everybody there, they're really nice, and we're all happy to offer our advice to each other. It's kind of like great community, yeah. We all want to help each other and strive to get better. It also helps on the academic level because at the beginning of the year, we got to choose some of our electives for the school, and I actually chose design and modeling and advanced technology as some of my electives because Vex has really influenced me. Before I did Vex, I didn't really know what I wanted to do with my life when I'm older, but now
I'm still trying to figure that out too.
now I actually want to go into computer programming or robotic engineering. So yeah, it's also a great responsibility because when you have a team of 4 people, everybody needs to be doing their part when they need to be doing their part. If any one of us slacks off or isn't doing what we're supposed to be doing, then the whole team fails. And Mr. Walsh is always pushing us to be better. When there is something that needs to be done, we do it quickly and we do it efficiently. And
At least we try.
yeah. And then Vex also teaches us a lot about engineering because if I do go into robotic engineering, I'm sure what I take away from the Vex experience will really help me because when I started, I probably couldn't tell the difference between a cap nut and a collar. But now, along with the help of my teammates, we can build an entire robot. I just think it's so amazing. And yeah, Vex is really nice. It's a great one.
As Christian was saying, it's a huge responsibility. And this year, the Varsity Robotics Club, we meet twice a week, normally. So on Thursday and Wednesday. And sometimes we'll meet on Friday or